When I was a child, there was a tree, and it was the perfect tree. I loved the tree. I have so many memories with the tree. But it was chopped down to make room for the bank. Cruella de Evil's bank. It's the worst day of my life. It's time for revenge. I began recruiting the best criminals to orchestrate the robbery against Cruella de Evil's evil bank.
Who should I collect for my gang of criminals?
The plan was to hop through the window of the bank, take out the guards, steal the money, make our great escape, and then celebrate. First, I collected the great acrobat Avery, quite possibly the best gymnast of the century. She can dodge any laser, make her way through any maze with such grace. Next, I got the sewer dweller Mahonri. His many strange tools allow him to do unknown things in his tunnel of doom. Also, the great hacker Katrina. No computer is safe from her. Look at those fingers fly. And she broke the keyboard. Katja, the organist. Nobody knows who she is or where she came from, or what she can do. But I knew I wanted her for my team. For obvious reasons. With the ball, we put the plan into action.
So the behavior of the ball in our heist can be modeled by a spring problem. And a spring problem is represented by this equation right here.
It's smiley face equals a times b to the power of x times cosine b theta minus h plus k. So the spring problem equation is comprised of two different parts. A cosine, because it cycles on a constant period, and then an exponential, because it's decreasing
at a decreasing rate. Okay, so first we're solving for the exponential part of this equation. So because the ball is at a height of 128 centimeters, after Avery jumped off, we know that our A value is 128. So to find B, we can take points from the graph and plug it into the equation y equals a times b to the x. So we're plugging in this point first to get 64 equals a times b to the first power, and then plugging in this point to get 32 equals a times b squared. So in order to find the ratio, which is the b value, we can divide the two equations by each other, which eliminates the a's, and then leaves you with 2 equals b to the negative first power, because you subtract the exponents when you divide, which equals 1/2.
The cosine half of it cycles on 2 pi when it's on the unit circle, but this obviously isn't, since every point is 1 second apart. So to find out what the cycle is scaled up or down by, we find the ratio between 2 pi and what it now cycles on, which can be represented as 2 pi over b equals the period, and the period is 1. So we set 2 pi over b equal to 1, which is 2 pi.
So in some equations of a spring problem, there is horizontal or vertical shift, but in this case there is none, and that's because we started at 0 seconds, and the value of 0 was like the level of ball, so we didn't have to shift up or down. But if you did need to shift it horizontally or vertically, the h shifts it horizontally and the k value shifts it vertically. So we don't have, both of those are 0, which means that we have all the parts of our equation, and this is our final equation. Y equals 128 times 1/2 to the x times cosine of 2 pi theta. And with this knowledge in store, Avery was successfully able to complete her heist and jump into the bank at the perfect angle, and we measured the behavior of the ball exactly.
We interrupt our program to bring you this important message.
Hey Fiona, what are you doing?
Oh, I'm just picking
Why berries?
swing the bat.
When you are doing binomial multiplication, do not forget the guts. Go, 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 go! Go, 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 go!
Go, 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 go!
Go, 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 go!
Go, 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 go!
Go, 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 go! Go, 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 go! Go, 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 go!
This is the safe. We don't know the combo, so Avery's launched 2 foci and is tracing around them with a laser so we can cut an ellipse-shaped hole in the safe and get the money. Nice.
So we know that the vault and the sensors that would detect intrusion are in the center of the panel. So in order to cut a hole out with lasers that would not trigger any of the sensors, we knew that we had to be 8 away from the lock in either direction, and that we had to be 6 inches above in either direction.
The center of our ellipse is at 0,20 inches above the ground, and our foci are each 8 inches away from the center. Our ellipse is 12 inches high, so from that we can get the B value and the C value and the H and K value, and with this we can find the equation of the ellipse. The equation of an ellipse, in this case, because it's horizontally oriented, is x minus h squared over a squared plus y minus k squared over b squared equals 1. From our center, we can get our h and k values. The center is 0,20, so that makes our h value 0 and our k value 20. From here, we can plug this into the equation. So we'll just have x squared, because you don't have to subtract anything if it's 0. And then we'll have y minus 20 squared. Our ellipse is 12 inches tall. This vertical axis, or the minor axis, represents twice the amount of the b value. So, if the minor axis equals 2b, then 12 equals 2b, and b equals 6. Then we can plug this into our equation, and 6 squared equals 36. Our foci are each 8 inches away from the center, which gives us our C value, which is 8. We can use the equation for foci, which is c squared equals a squared minus b squared, to find our a value. So if we plug in 8 for c, we'll get 8 squared equals a squared minus b squared, so minus 6 squared. Then if you multiply that out, you get 64 equals a squared minus 36. You can then add over the 36, and you have 100 equals a squared. And then if you take the square root of 100, you get that a equals 10. So then, to put that into our equation, we can square A again and have 100. The final equation for this ellipse is x squared over 100 plus y minus 20 squared over 36 equals 1.
The quickest way to escape bank is via slides. But in order to measure, we need to know the concavity.
The graph of the slide is represented by a cubic. To find the point where the concavity switches, you find the derivatives. So to do the first derivative, you take this 3 times the negative 3.6, which is negative 10.8 x, and then this third goes down by 1, so it becomes squared. Plus this 2 times that 2 is 4 x, and then this squared becomes to the 1. Plus this is x to the 1th, so this times the 2, and this x to the 1 becomes x to the 0th, which is 1.
To find the second derivative, we repeat the process that we just did, and we end up with 21.6x plus. To find the concavity where it switches, you set negative 21.6x plus 4 equal to 0. First, you carry over the 4, so then you get negative 21.6x equals negative 4. Then you divide all that by negative 21.6. And then we end up with x equals 5/27.
To express this as a range, you would write it as it's concave up from negative infinity is less than x, which is less than 5/27 to here, and it's not going to equal 5/27 because right here where the concavity switches, it's neither up or down, which means that it's concave down from 5/27 is less than x, which is less than positive infinity.
So at this point, we had all of the math needed to put our plans into action. So we started with Mahonri, who took the workers of the bank out and distracted them with nothing else than his scissors, of course. Meanwhile, Avery cut a hole into the side of the bank and jumped through to grab their money, while Fiona engaged the last guard in a pretty epic lightsaber battle. Katrina did something with computers, while Katja, well, no one really knows what Katja did. Piano? But anyways, the point is it worked. No one found us. We weren't caught. No one suspected us. Well, we'll see if that ends up being the case. But being the smart villains that we were, we decided to celebrate. Of course, we stayed on.